define and analyze an atmospheric crude column. In this video, you will construct, run, analyze, and manipulate an atmospheric crude fractionation column in Aspen hysys. You will begin with a hysys reflux absorber template and continue by adding side operations and additional specifications to the column model. The final focus will be to utilize cut point specifications on the column model to increase and better define product quality. Atmospheric crude columns are one of the most important pieces of equipment in the petroleum refining industry, typically located after the desalter and the crude furnace. The atmospheric tower serves to distill the crude oil into several different product cuts. These typically includes naphtha, kerosene, diesel, and atmospheric gas oil. This video includes the following tasks. Task 1. Add column template. Task 2. Introduce site operations. Task 3. Adjust column operating conditions. Task 4. Product stream analysis and cut point specs. Task 1. Add the column template. The feed to the atmospheric crude column is typically a raw crude that has been preheated and treated. Continue with the simulation file from the preheat train video, the one with the balance and adjust operations installed. If you cannot locate this file, load the attached file with this video. Add a material stream. Change its name to bottom steam. Set the vapor fraction to 1. I set the pressure to 1379. Set the mass flow to 3400 kg per hour. On the composition page, set the mole fraction of water to 1. The atmospheric column will be simulated as a reflux absorber. Add the reflux absorber from the model palette. View the column input expert. Change the column name to atmospheric column. Under 29, add the number of stages. This will set up 29 theoretical equilibrium stages along with a theoretical stage at the top of the column representing the condenser. Select bottom steam at the bottom stage inlet. Select atmospheric feed as an optional inlet stream and list its inlet stage as 28 main tower. Leave the condenser selected as partial, with off-gas and naphtha listed at the 2 overhead outlets. Check the water draw checkbox and specify wastewater at the water draw stream name. Please note that including a water draw allows hysys an exit stream for any immiscible water that may be present in the column stages. This is vital in this type of atmospheric crude column as the steam is fed in at the bottom stage. Not all stream will be miscible in the hydrocarbon, gas and liquid phases. Therefore, we must allow an out for this excess water in order to maintain a material balance around the column. For the bottom's liquid outlet, specify a stream titled atmospheric residue. Enter a condenser energy stream titled condenser duty. Click the next button to move to the next page of the input expert, the pressure profile page. Enter a condenser pressure of 140 kilopascal and enter a condenser pressure drop of 60 kilopascal. Enter bottom stage pressure of 230 kilopascal. Click the next button to move to the optional estimates page, where you can provide temperature estimates for the column. Remember, these are purely optional. If you do not have this temperature information, it's best to leave this form blank. In this case, you do have temperature profile estimate data. For the optional condenser temperature estimate, enter 40 degrees centigrade. And enter optional top stage temperature estimate of 120 degrees centigrade. And finally, enter optional bottom stage temperature estimate of 340 degrees centigrade. Move to the next screen of the input expert. Enter 0 kilogram mole per hour for the vapor rate. Leave all other inputs empty. Click the Done button. Move to the Design Monitor page and check the distillate rate and reflux ratio specs and any other specification that do not have a value. Check the active box for the vapor product rate specification. As you can see, the degree of freedom is 1. Therefore, one additional input is required before the atmospheric column will begin to solve. Specify a distillate rate spec of 150 cubic meter per hour. Double-click on the distillate rate. As you can see, by default, flow rate specs are on a molar basis. Change it to volume basis. Enter a value of 150. Check the active checkbox for the distillate rate. Now the column has converged. This concludes the first task. Task 2. Introduce site operations. We now need to add the site of product draws for the other products from the column: kerosene, diesel, and atmospheric gas oil. Each of these products is removed through side strippers, which help control the quality of the product. There are 2 types of side strippers available in Aspen hysys: reboil and the steam strip. We will install 1 reboiled side stripper and 2 steam stripped side strippers. Pump arounds help to improve the column's efficiency. They operate by drawing a liquid steam from one stage, cooling it, and then pumping it into a higher stage. In effect, this process removes heat from the column that would otherwise have been removed in the overhead condenser. By removing the heat along the column at a higher temperature, they enable greater heat recovery. They also have the secondary function of controlling the liquid flow reflux in different sections of the column. The first site operation of each type will, will be added using the site ops input expert. This tool is designed to simplify the process of adding site operations to the column, much like the column input expert simplified the initial setup of the column itself. Move to the site ops tab of the atmospheric column property view. Click the site ops input expert. The site ops input expert is really 5 experts in one interface. The first page of the input expert is for adding reboiled site strippers. The second page for adding steam stripped site strippers, etc. All site operation type have a dedicated page in the input expert. Click the next button to move to the steam stripped site strippers. Click Add Site Stripper button. Change the name to Atmospheric Gas Oil Site Stream. Set the return stage to 21 main tower. And the draw stage to 22 main tower. Name the steam feed Atmospheric Gas Oil Steam. And name the draw product Atmospheric Gas Oil Product. Click the Install button. The next site operation that we will add is the bump around for the atmospheric gas oil section. Again, this operation will be added by using the input expert for bump around operations. Click the next button twice to get to the bump around section of the input expert. Click Add Bump Around. Change the name to Atmospheric Gas Oil Bump Around. Set the return stage to 21 main tower and the draw stage to 22 main tower. Click Install. Close the site ops input expert view and return to the design monitor page of the atmospheric column. Again, the design monitor page is used to govern the specifications that control the operation and calculations of the column. Note that the specifications related to the two site operations you just added are listed in the specification tables. In total, the two site operations contribute 3 degrees of freedom to the column. Therefore, 3 active specifications in addition to the distillate and vapor product rates are required before the column will be able to solve. The 3 specifications that you will add are atmospheric gas oil side stream product flow and atmospheric gas oil bump around rate and atmospheric gas oil bump around duty. You only have to enter the specified value for the specification you want to select them as active. Set the atmospheric gas oil side stream product flow to 30 cubic meter per hour. And set the atmospheric gas oil pump around rate to 200 cubic meter per hour. And finally set the atmospheric gas oil pump around duty to 35 million BTU per hour. Remember that the side stripper you added is a steam stripped side stripper. You created a steam stream to be associated with this side stripper a few steps ago. This steam stream is essentially another column inlet, and therefore it must be fully specified before the column can recalculate. Return to the main flow sheet. Open the property view for the atmospheric gas oil steam stream. Set the temperature to 150 degrees centigrade and set the pressure to 345 kilopascal. Set the mass flow to 1150 kilogram per hour. On the composition page, set the mole fraction of water to 1. Return to the design monitor page of the atmospheric column. Ensure that the degrees of freedom is 0. Click Run. Two more side operations need to be added to the atmospheric column, a reboiled side stripper and a third pump around. These side operations are dedicated to the isolation of kerosene product draw. Move to the Side Ops tab. Click Side Ops Input Expert. On the reboiled side strippers page, click Add Side Stripper. Change the name to Kerosene Side Stream. Set the return stage to 8 main tower and the draw stage to 9 main tower. Name the draw product kerosene product. Then click Install. Return to the design monitor page of the atmospheric column. Set the kerosene side stream product flow to 62 cubic meter per hour. Keep the default kerosene side steam boil up ratio 0.75. Ensure that the degrees of freedoms is 0. Return to the Side Ops tab. On the Pumps Arounds page, click Add to introduce a third pump around. Change the name to Kerosene Pump Around. Set the return stage to 8 main tower and the draw stage to 9 main tower. Click Install. Set the kerosene pump around rate to 330 cubic meter per hour. And set the kerosene pump around duty to minus 42 million BTU per hour. Now return to the design monitor page. Ensure that the degrees of freedoms is 0. Then click Run. This concludes the second task. Task 3. Adjust column operating conditions. To model this atmospheric crude column, you utilized a reflux absorber template. This reflux absorber doesn't have a reboiler of any kind associated with it. However, a side exchanger that introduces some heating duty can be simulated near the bottom of the column by attaching an energy stream. This attached energy stream represents an additional degree of freedom for the system and would thus need to be defined or calculated via some other specification. On the main flow sheet, add an energy stream. Name this stream trim duty. Open the atmospheric column property view and on the design connection page, add the trim duty stream in a new external stream cell and specify stage 28 as its inlet stage. As you can see, the design connections form looks much different than it did when you first created the atmospheric column. Remember, the design connection page formerly showed a basic schematic of the column, streamlines and stream names next to each streamline. The atmospheric column now features so many inlet and outlet streams. It would be impossible to represent them in a reasonable schematic. Therefore, hysys uses this tabular view to list the connected streams. To help understand the terminology used on the design connections form, here is some definition. Inlet streams, material energy streams that flow into the column model. Outlet streams, material energy streams that flow out of the column model. Internal streams, a material energy stream that exists inside the column subflow sheet. External streams, a material energy stream that exists outside of the column subflow sheet environment. External streams merely represent the column internal streams out on the main flow sheet. Since you added an energy stream that's not fully defined, 1 degree of freedom exists for the column. Therefore, you need to add another specification to atmospheric column in order for it to solve. Go to the design monitor page and click Add Spec button. Choose column liquid flow. Click Add Spec. Change the name to Overflash. Set the stage to 27 main tower. Change the flow basis to standard ideal volume. Set the value to 23 cubic meter per hour. Ensure the active box is selected for the new overflash specification. Uncheck the active box for the kerosene side stream boil up ratio. Set the kerosene side stream reboiler duty to 75 million BTU per hour. Check the active box for this specification. This concludes the third task in this video. Before we start task 4, we added side stripper and bump around for the diesel product. The diesel side stripper is a steam stripper. The liquid rust stage is 17 and the vapor return stage is 16. As for the diesel bump around, the draft stage is 17 and the return stage is 16. The diesel side stripper product flow is 130 cubic meter per hour, and the diesel bump around rate is 200 cubic meter per hour. Finally, the diesel bump around duty is minus 36.93 million kilojoule per hour. Now to task 4, product stream analysis and cut point specs. The atmospheric column is now being solved using product flow rate specifications. Flow rate specifications are probably the easiest to understand conceptually. However, they are also the most inflexible way of defining the column. If the feed flow rate were to change substantially, for example, the column may fail to converge because the material balance couldn't be closed. Taking another approach, it may be desired to maximize the production of particular product cut, such as kerosene. One could simply increase the kerosene flow rate spec, but this may negatively influence the quality of the kerosene product. Therefore, another method of specifying the column might be more effective in order to focus on column product quality. One of the most common ways of doing this is to use cut point specification to define the product streams. One of the stream analysis features in aspen hysys, the petroleum assay analysis, can be used to show the distillation cut points under various bases. For example, through boiling point, ASTM, D86, etc. So, for example, you could attach petroleum assay analysis to the kerosene product stream and check the current calculated cut points. From there, you could target a wider cut point range using appropriate column specs to maximize production of kerosene. Before you maximize the production of the various products, the base case needs to be defined. Attach petroleum assay analysis to the 4 primary atmospheric column products: naphtha, kerosene, diesel, atmospheric gas oil. Record the D86 cut point temperatures for the 5% and the 95%. To maximize the production of a certain product draw, for example here naphtha, it's necessary to increase its 95 volume percent cut point temperature. At the same time, the kerosene 5% volume percent cut point temperature will show a corresponding increase as the lighter kerosene components are transferred into the naphtha product, becoming the heavier naphtha component. By changing the flow rate specification for both the naphtha and kerosene product to STM D86 95% volume cut points, we can maximize the production for each naphtha from the column. Return to the atmospheric column property view. Navigate to the design monitor page and check the active box for both distillate naphtha rate and kerosene side stripper production flow. Click Add Spec, choose column cut point. Set the stage to condenser. Set the cut point to 95% and enter a value of 215 degrees centigrade. Add another column cut point for the kerosene product. Set the stage to kerosene side stripper reboiler. Set the cut point to 95 and enter a value of 260 degrees centigrade. As you can see, the column has converged. This concludes the last task of this video. Thank you for watching.